Hi, I'm Andrew Nayrud. For my Explorations project, I investigate hybrid quantum neural networks, or HQNNs, to see whether combining quantum circuits with classical deep learning could make image classification models more efficient. I hypothesized that hybrid models might match the performance of standard CNNs while using fewer parameters and lower computational cost. To test this, I used the MNIST handwritten digit dataset and built models with TensorFlow and PennyLane while using NumPy for data handling and Matplotlib for analysis. I trained both a classical CNN and an HQNN by inserting a variational quantum circuit into the midsection of the network, replacing one dense layer. Both models use multiple convolutional layers to reduce image dimensionality before classification. For the HQNN, I designed the circuit with 4 qubits. I embedded classical data into quantum states using angle embedding and followed those with 3 entangled layers that had a total of 12 trainable parameters. After those layers, the results were passed back into the classical model. Overall, the results were quite promising. One HQNN reached over 97% accuracy, just 1.5% less than the classical models, while using 88% fewer parameters and 63% fewer floating point operations, or flops. This suggests quantum layers can significantly compress models with minimal accuracy loss. However, the HQNN took nearly 2 hours to train, compared to just 3 minutes for the CNN. Along the way, there were several challenges. Training was slow because quantum simulations on classical hardware are expensive. I also couldn't reduce training time without hurting accuracy. I tested other encodings as well. Angle encoding worked well, but amplitude encoding was hard to scale due to batching issues in current quantum libraries. However, HQNNs show overall promise for compact models, but real-world use is currently limited by training costs and hardware support. Looking ahead, I'm exploring HQNNs in dynamic tasks like multi-agent reinforcement learning. I'm testing to see whether quantum-enhanced models can help agents coordinate faster or explore more efficiently. On screen is a training session in AirSim. A drone captures image input to guide a separate car along a path. They run in separate simulation instances connected through a shared backend. I will later integrate an HQNN and compare these models. Thanks for watching. I'm excited about the future of quantum-enhanced learning systems.